Hey everybody, today we're going to be finishing off the solutions unit with lesson 7. We will going to be taking a look at some solubility graphs today. But for the past 2 days, we have been working with our lab skills, learning how to make a standard solution from a mass and a standard solution by dilution. So for today's review, we're going to ask you procedurally, what differs between creating a standard solution and a standard diluted solution. So take a moment. When you're done, you can unpause the video and then you can compare your answers. So the main difference that we have in a standard solution is it's created using a mass of a compound. So created using a mass dissolved in water. So we're actually taking our compound, we're weighing it out, and we're dissolving it into water. What happens when we do something from dilution, it's actually created from a stock. It's created from a stock solution. So let's say we have a solution of 0.1 molar and we want to dilute it to 0.01 molarity. We would take a volume from the stock solution and then dilute it with the appropriate volume. Okay, and it's usually pipetted. So you have to use a pipette from the stock solution. So it's usually pipetted from the stock solution. Okay, that is basically the main differences. Everything else is pretty much the same. You're using a volumetric flask, you're calibrating to the line. Okay, so let's get into working with graphs now. So basically, the way that the graphs are set up, they have temperature on the x-axis, which means that temperature is our manipulated variable. Okay, just reviewing general graph. This is our manipulated variable. And then on the y-axis, we have our responding. So basically, in this graph, what's happening is we're changing the temperature and seeing how the solubility of different compounds will change. So I'm going to get a highlighter out. Okay, so let's take a look at this first line here. We notice that it kind of curves up. Don't know. Okay, so here's our first line. We're taking a look at solid A. At 20 degrees, what happens is it has a solubility of about 34 grams per 100 grams of water. So basically, how solubility is written is, let's say we're looking at the solubility of solid A. So at solid A, at 20 degrees Celsius, is equal to, I'm going to say it's a little past half. I'm going to say it's about 34 to 36 grams per 100 grams of water. Basically, this is what it's saying. So when you put solid A into water, and the water temperature is at 20 degrees Celsius, it can dissolve up to a maximum of 34 grams in 100 grams of water, or 100 milliliters of water. So that is its solubility. That's all it can take at 20 degrees Celsius. If I were to put, let's say, 50 grams of solid A at 20 degrees Celsius, it would dissolve up to 34 grams of it, and then we would see some of the powder or some of the compound kind of settling at the bottom of the beaker because they can only dissolve a maximum of 34. Okay, so if I'm trying to get up to 50 grams in 100 milliliters, I would have to raise the temperature 50. So we're going across. I would have to raise the temperature above 35 degrees Celsius for it to be able to dissolve 50 grams of that solute, okay? So basically this is what this graph is saying. So now it's saying which compound has a higher solubility at 40 degrees Celsius. Okay, I'm going to clear up my graph and then we'll come back. Okay, so going back, the question is asking which compound has a solubility of 40 degrees, the highest solubility of 40 degrees Celsius. So what I'm going to do is I'm going to find 40 on the graph. There it is. And I'm going to read up. Okay, so we want to look for the highest line. This is my highest line. This line connects to solid B. So the highest solubility at 40 degrees Celsius is solid B. Okay, now it's saying which compound has the highest solubility at 70 degrees Celsius? So we go back to our graph. We find 70 degrees on our x-axis, and then we read up. Okay, and we see this line. This line refers to solid A. So now, at 70 degrees Celsius, solid A has a higher solubility, okay? I'm not going to be asking you to do any weird calculations. At this point, we are just reading the graph. Okay, so now we're going to move into interpreting these graphs. So here I have a graph and there's a lot of compounds on it, okay? So it's going to be a little difficult to read. That's okay. Let's see what it's asking. The first question is asking solubility of ammonium chloride. Okay, let's write that chemical formula. Ammonium chloride is NH4Cl. We're looking for the solubility of ammonium chloride at 60 degrees Celsius. I'm going to find 60 degrees. And I see ammonium chloride right there. And then I'm going to read across. I would say that the solubility of ammonium chloride is about in between right here, between, see if I can draw a nice straight line. Okay, so at 60 degrees Celsius, it's about 55 grams per 100 grams of H2O. So again, what that means is at 60 degrees Celsius, I can dissolve a maximum of 55 grams of ammonium chloride in 100 grams of water. Okay, let's look at the next one. The solubility of potassium nitrate. Okay, potassium nitrate looks like this. KNO3. Okay, so let's reset our graph. Scroll up. We're looking for potassium nitrate at 70 degrees. So I'm going to find 70. There's 70. And potassium nitrate, the line is up there. So I'm going to read up. So I follow this line up. And then as soon as I touch that potassium nitrate line, which is this curve here, I'm going to read across. I would say that my solubility of potassium nitrate at 70 degrees Celsius is about 130. So 130 grams per 100 grams of water. Okay, now let's get into interpreting graphs. So it's asking, would 30 grams of potassium nitrate fully dissolve at 10 degrees Celsius? Okay, so let's clear out this graph again. So it's asking us, would 30 grams of potassium nitrate fully dissolve at 10 degrees Celsius? So I'm going to find 10 degrees. It's right there. And I'm going to bring my line up until I hit that potassium nitrate line. Okay. I'm going to highlight that line just so it's a little bit easier to see. So we're going, let's use a different highlighter. Okay, so let's highlight this line. There's my potassium nitrate line. And if it helps you, feel free to highlight the line as well. I don't know why my line is correcting itself. Give me 1 second, I'll be back. Okay, so there's my potassium nitrate line. Now we want to compare it at 10 degrees Celsius. So at 10 degrees Celsius, I reach my line, and it can take a maximum of 20 degrees. I mean, at 20 grams at 10 degrees Celsius. So I'm going to go ahead and scroll down, and then, so would it be able to fully dissolve 30 grams? No, because it can only dissolve a max of 20 grams at 10 degrees Celsius. Okay, so going back, it can only dissolve up to 20 grams. So if we were to add 30, we would end up with a little bit of our compound that's left undissolved. Okay, the next question is asking us which compound experienced the least amount of change. So when you're looking at a compound that experiences the least amount of change, you're looking for your flattest line. So I'm going to get another highlighter here. We're going to identify our flattest line. I see our flat line, and it's right here. That compound is NaCl. So let's go back down. So sodium chloride is our compound that experiences the least amount of change. NaCl. Perfect. Which compound experiences the most amount of change? So this is the one, this is going to be the line that has the most sharpest or steepest line. And we can see that our potassium nitrate has the most sharpest, steepest line. So it's experiencing a lot of change as temperature goes up. So it's going to be potassium nitrate. Okay, the last question I have here, I'm going to leave this one for you to answer on your own, and then when you are done, you can come back and unpause and check your answer. What would happen if more than 100 grams of potassium nitrate was added at 50 degrees Celsius? Okay, so we're looking at our potassium nitrate, and we are looking at it at a 50 degrees Celsius. I'm going to bring my line up. And at 50 degrees Celsius, it looks like it can take about a maximum of 80 grams per 100 grams of water. So would it be able to fully dissolve 100 grams? No, it would not. There would be excess. And that excess compound would not be able to dissolve. All right, the last thing that we're going to do with solubility is we're going to calculate solubility. So we will be given situations where they have given us a snapshot of a certain amount of compound dissolved at a certain temperature for a certain amount. We know that solubility is equal to blank grams of our compound dissolved in 100 grams of H2O. So this is the form that we need to put it into when we are identifying solubility. Okay, coming down here. We have 50 milliliters at 30 degrees Celsius, making a standard solution of sodium sulfate. If the solution evaporated to dryness and 46 grams of sodium sulfate decahydrate crystals was left, what was the solubility at this temperature at 30 degrees Celsius? So I'm going to set up a ratio. So there was 46.4 grams of solute dissolved in 50, ooh, that should be a 50, dissolved in 50 milliliters of water. I want us to be very clear, so I'm going to go back up here and give you a little hint. 100 grams of water refers to 100 milliliters of water as well. So solubility can also be equal to 100 grams per 100 milliliters of water. Because the density is the same, it's 1 to 1. So 100 grams of water is 100 milliliters of water. Okay, so we're looking for our X amount of grams per 100 milliliters of water. So what we're going to do is find X, okay? So I'm going to isolate for X. X is equal to 46.4 grams multiplied by 100 milliliters divided by 50 milliliters. Once I plug that all in, I find out that X is equal to 92.8 grams. Okay, we have our number there. So solubility. Solubility is equal to 92.8 grams per 100 milliliters of water. Okay, so there is our final answer. Oh boy, that's H2O. There's our final answer. Okay, let's do that one more time. Example 2 says I have 40 grams of KCl that will dissolve in 200 milliliters of solution at 40 degrees Celsius. What is the solubility of KCl? Okay, so same thing, you're going to set up a ratio. 40 grams dissolved in 200 milliliters of water. Make your ratio. We are looking for our X amount of grams that will dissolve in 100 milliliters of water. Then you isolate for X. X is equal to 40 grams multiplied by 100 divided by 200 milliliters. Milliliters cancels out, and I'm left with 20 grams. So now, solubility is equal to 20 grams per 100 milliliters of H2O. And this happens at 40 degrees Celsius. This is our final answer. Okay, the last example is for you to try. So we have 42 grams of sodium iodide dissolved in 60 milliliters of water or solution. What is the solubility of sodium iodide? When you are done, you can unpause and check your answer. Okay, once you plug that in, isolate for X. Your final solubility at 40 degrees Celsius is 24 grams per 100 milliliters of water.